All right, what up, y'all? Welcome back. We are in Math 2B, Applied Linear Algebra. We're working on Lesson 10, Problem 5. I'm sitting in office hours with Nobu-san and Veronica. They asked this beautiful question, which was this problem. Amazing thing about these students is they actually came with the question ready to ask. So we'll go ahead and write this, read it for ourselves out loud as we make this video. Do you all want to say hi so they know you're here?
Hi.
Hi.
Yeah, they're here. They're making me work, so we'll see if I earn my paycheck today. All right, so we have this 3 mass, 1, 2, 3 mass, 4 spring, 1, 2, 3, 4 spring system. The problem says, please consider the mass spring chain above. Let's recall the model for the mass spring chain is given by m u double dot of t plus k u of t equals f sub e of t. And then it says, please identify the stiffness matrix for the given value of k sub I. So each of these springs, it looks like spring 1 has a stiffness of, what is that? 300 newtons per meter. Spring 2 has a stiffness of 200 newtons per meter. And spring 3, same 200 newtons per meter. And then spring 4 is 300 newtons per meter. Do you want to say out loud so that all of our audience can hear your question?
Well, I just wanted to know how you came to the stiffness matrix. A classmate found this formula here, but I want to know how this was derived and then to get that answer.
Okay, so let's see. You are now my boss in this whole situation. The whole goal here is to do this. One of the things I really like about Veronica is that she came to office hours with this already done, ready to ask. And so it took her like 1 minute to ask me this question, which is really powerful. That's a great study skill. Well, we knew that K was going to be A transpose times C times A, but we also know what A transpose is, right? Because we've actually constructed A and A transpose once before. Don't be, it's taken me a long time to memorize these off the top of my head, so generally I would have had to go back and look at that thing, right? Okay, what's on the diagonal of C?
Yep.
K1.
Yep, so we'll call this thing K1, 0, 0, 0, 0, K2, 0, 0, 0, 0, K3, 0, 0, 0, 0, K4. And then over here, what do we got?
A or
Yep, 0, 0, 0, 0, 1, negative 1, 0.
0, 0, 1, negative 1.
Okay, so the question is, what kind of mood are you in today? Are you in a row mood or a column mood?
column.
Okay, you're in a column mood. So then let's take linear combinations of these columns using these coefficients, shall we? Okay, so let's see. Column 1, if I'm going to do a column partition, what does column 1 say? I'm going to take 1 of column 1 and add it to
Column 2.
negative 1 of column 2. How many of column 3 and column 4?
0.
0. So I'm not going to touch this matrix over here, right? This matrix is, oh, sugar. This matrix is going to stay the same, negative 1, 0, 0, 0, 1, negative 1, 0, 0, 0, 1, negative 1. But what we've done is now we're going to associate these two together and do them. Okay, 1 times K1, 0, 0, 0, plus negative 1 times 0, K2, 0, 0. Well, can you see what that made? K1, negative K2, 0, 0. Okay. 0 times the first one, 1 times the second one, negative 1 times the third one.
0, K2, negative K3, 0.
Okay, and then the last one?
0, 0,
0, 0.
K3, negative K4.
Okay. And now, again, this is a 4 by 3, which makes complete sense because we've multiplied a 4 by 4 by a 4 by 3.
Yeah.
This one over here is a 3 by 4. What's the size of the output that we expect?
3 by
3 by
3.
3.
Must be a 3 by 3 by the constraints of the matrix multiplication problem. Now I would ask, are you in a row mood or a column mood? I might suggest that we get into a row mood right now, if that's okay with you. So let's take this row and multiply by, oh, actually, you know what we could do is entry by entry. So let's take that row and do the first column. 1 times K1, negative 1 times negative K2, K1 plus K2. The rest of them are 0. Let's do the next one down. So let's take this row and multiply by that column. 0,
K
So negative
Yep.
K2.
Negative K2, rest of them are zeros, right?
0, yeah.
Okay, so now let's do the third one and do that. 0, 0,
0, 0.
0, 0.
Mm-hmm.
Mhm.
Okay, so that's now what we would call the entry by entry definition of the first column, right?
Mm-hmm.
And I can already tell that the amount of space that I gave myself was not equal to the amount of space that I needed. Okay, so let's do the second one. So let's start with the first entry in the second column. 1 times this, negative 1 times that, 0, 0.
So negative K2.
Yep.
Negative K. Yeah.
Okay, so let's go to the next one. Row 2, column 2. 1 times K2
K2
plus K3.
K2.
You got it. Look at you. 2 plus 3.
0.
And then maybe I... Yeah, so you already jumped ahead of the game there, right?
Mm-hmm.
So let's take a look at the next one. 0, 0.
Negative K3.
Yep, you got it. Okay, and then let's go to the last one.
0, 0.
0, 0, 0,
0,
0. Must be 0. Let's go to the one down now. We're going to take column 3, row 2, which is that entry, right? Because that's the 2, comma 3. So row 2, column 3.
Mm-hmm.
0,
0,
1.
negative 3.
Yep. Negative K3. And then let's go to the last one. 0, 0, K3
3 plus K4.
plus K4.
Uh-huh.
Okay, but we already know from the problem statement that K1 was 300, K2 was 200, 3 plus 2 is 5, the hardest problem that we've solved so far, right?
I think this was the hardest part because that's just plugging in the numbers.
I guess that would be 400, negative 200, negative 200, and I suppose that would be 500 again, and 0. And that is now my K matrix.
Huh.
Donk, which means I can go back to the original problem that I've done and substitute that back in, right?
Mm-hmm.